recently, my dad and I begun working on the roof of our barn here. You see it leaks quite a bit, and we're trying to get a poker room built in right underneath here in my feet. So what I'm trying to do right now is, while he's at work, I figured I'd go in and hit some nails up here on the barn, fix any holes, and maybe spray some caulking anywhere that there's any leaks, or any visible leaks. Now, I thought since I was up here, this would make a great physics demonstration. Now you see, whenever I'm up here, I like to disperse my weight as wide as I can. And the reason for doing that is because I want to reduce the amount of pressure underneath me in one spot as much as I can. You see, the formula for pressure is P equals, I think it's N over A. Nope, that's not it. P equals F over A. That's force over area. Now, what that tells me is that the more force I have, or the smaller area I have, and the more force that is on that area, the more pressure there is underneath me. So, by dispersing my weight as even as I can, and moving my feet in little increments, making sure they are as wide as possible, I'm making sure to reduce the amount of pressure that I'm building on this roof as much as I can. Now, another thing to consider while I'm up here is the kind of shoes that I'm wearing. In this instance, I'm wearing my leather boots, and I would raise my foot up to show you, but then I'd only have one foot on my roof, and therefore there'd be a lot more pressure on one foot than there would be dispersed overall. So, nonetheless. Now, the thing is, boots probably aren't the greatest thing I could be wearing right now, because, well, obviously the heel on the back, there's a lot of pressure created from that heel, especially because that's what I'm putting a majority of my weight on as I'm climbing up this roof. Now, if I were to wear like deck shoes, like Converse or something, that would probably be a little bit better, because the area of the shoe is much larger, the area of contact between the shoe and the roof is much larger than the area of the boot and the roof. So, I probably am risking a little bit to be up here, but then again, I do find that these boots have a bit more grip up here, and while pressure on the roof is one great issue, obviously, slipping is another one, especially because it's still a little wet from here because it just finished raining not too long ago, I think. So, anyway. But, another cool thing, depending upon what you're standing on, you are either more or less likely to fall through the roof. As I'm doing this, I'm making sure to stand on the beams that go across here horizontally along the barn. So that way there's as much material underneath me as possible, to where any pressure that I do build or do create, it is at least supported by more material than to say if I were to stand here in between the two boards where there was nothing holding me up besides tin. Hi.
Yeah?
If I was a child, I'd be climbing on all fours.
Right.
But because I have so much confidence in my knowledge of physics, and I have so much trust in Sir Isaac Newton, along with his laws, and whoever the heck else also made whatnots for physics, I know that I should be perfectly safe. Besides, the amount of pressure obviously is measured in pascals, and being force over area using the metric system. So I'm willing to say, I don't know, I've probably got like probably not 1 square meter, probably like a quarter of a square meter or something like that, like 0.25 meters squared for my area. And my force being in newtons, so I'd have to convert the amount that I weigh in pounds to kilograms, and then convert that to newtons for force. So I weigh 220 pounds, so we'll just call that like, let's call it like 100 kilos, 100 kilograms. It's probably like 95. I don't know the exact measurement. So we'll say 95 over, right now we'll just do 100. 100 newtons over 0.25 meters squared. So that would be 400 pascals. Hey, yeah, no, I did that wrong. I forgot to convert kilograms to newtons. So in reality, that would actually be going off the numbers that I used. So I got to 100 kilograms, so transferring that to or converting that to newtons, that'd be actually 980. And putting that over 0.25, that'd be like multiplying 980 by 4. So give me a second, because it's it's been a while since I've gone to school. So that'd be 4,920, if I'm not mistaken. Nope, that's not right. It's actually 3,920. That's what that is. Now, I don't know if that's a lot or not, but if I were to reduce my area and put both of my feet together like this, my area is much smaller, which would mean that I would end up with a much larger pressure. So in this case, we'll call this like 1/10 of a square meter, so like 0.1 meters squared. And that would mean that it'd be, so 100 divided by 0.1, which is just 100, so it'd be 1,000 pascals. Yeah, no, that is definitely wrong too, because once again I forgot to convert to newtons, so that would actually be 100 times, so 980 like last time, over 0.1, so that'd just be 9,800 pascals, or just 9.8 kilopascals. So simply moving one of my feet over that much reduces my pressure created by an enormous amount. But if I were to stand on here on like 1 foot on my tippy toes or something, there's no telling how large that would be, because like I said, I'm not being super accurate here. I guess I do have a tape measure, but I'm not going to take the time to do that because I do kind of have some work to do. But nonetheless, I guess that's my demonstration of pressure in physics. Thank you.